Good morning, everyone. This is an initiative of NFE, National Federation of Engineers for Electrical Safety. NFE's vision is to make every electrical installation free of accidents such as electrocution and fire due to short circuits, and increasing the reliability of electrical installations, thus contributing to the saving of life and property and supporting sustainable development. NFE's mission is to achieve our vision through getting accredited for product and personal certification. What NFE does is to create awareness on electrical safety, improve skills of practicing electrical engineers, improve safety measures followed in industry, introduce modern safety measures in engineering, and improve electrical safety throughout our nation. This webinar is about IS 3043 Code of Practicing for Earthing. Today our speaker is our president, Mr. Gopakumar. Mr. Gopakumar is an electrical engineer. He is the founder and promoter of Cape Electric Private Limited, Cape Electric Power Production Private Limited, LP Consultants International Private Limited. He is a member in the technical committees of BIS and IEC, ETD 20, ETD 30, and ETD 50, and IEC 3C64, TC 81, SC 37A. Over to you, sir.
Thank you, Lakshmi. Good morning, all the participants. Good morning to everyone. Today we have a record number of registrations. I think people, if you are getting disconnected in between, maybe due to overcrowding, you may be diverted to the YouTube channel. So you will be able to view it. Nothing to worry. Today we are going to have one of the most very serious webinar on earthing, the new code of practice, IS 3043. Now, actually, in the morning we had a small trouble. Mr. Dominic, generally who used to start the session, today morning there is some problem in the internet connection. As a result, he could not join properly. But anyway, I hope my screen is visible to everybody. Lakshmi,
Yes,
can
sir.
you confirm?
Yes, sir.
Okay.
It is clear.
Thank
Sir.
you. So today we are going to discuss about one of the most important subject of electrical installation, which is earthing, code of practice of earthing. For your information, the new code of practice of earthing draft has been published by BIS a few days back. This is the IS 3043 third revision. This time, this is a revision. It's not an reaffirmation or whatever. This is a revision which contains a lot of changes, fundamental changes in the document. Now, to have a look before having a look into the document, I would like to explain a little bit about the historic way or historic subjects of discussion. For example, what you are seeing in the screen is the IE Rule 1956. In 1906, the first definition of earth was made, and it was defined as connected to the general mass of earth. 1956 IE Rule, which was the officially available document, the oldest document available in India, for example. Here, earthing or earthed is defined as earthed or connected to earth or connected with earth means connected with the general mass of earth in such a manner as to ensure all time and immediate discharge of energy without danger. As a result of this definition, we always were thinking that earth or earthing means you connect through some means, you connect it to an earth electrode in soil. As a result, all the unwanted energy goes to the soil and we become safe. This was the concept during the initial days of the distribution, 1956 or whatever. In 2010, the IE rule has been changed to CEA, measures relating to safety and electric supply regulations. Here also, the same definition continued. Earthed or connected to earth means connected with the general mass of earth in such a manner as to ensure all time and immediate discharge of electricity without danger. Here also, the idea which was given to the users is you make something in soil. As a result, the energy goes to earth. This was the definition predominantly followed in the country. Similarly, in 2023, there was a big change. The 2023 CEA regulation has changed the definition. I don't know how many of you have really noted it down. Here, there was no earth or earthed. The definition of earthing was defined. Earthing means connection of exposed conductive parts, conductive and extraneous conductive parts, and installation to the main earthing terminal of the installation. That means in a building, earthing means your exposed conductive parts and extraneous conductive parts are connected to the MET, one common bus bar, or connection of neutral of transformer or generator or equipment to the general mass of earth, depending upon the situation. In a building, you have to do it in one way. If your installation is in soil, you need to do it in a different way. The general mass of earth or earth bonded bar of the installation. So basically, in 2023, there was a big change in the definition. When we make our webinars and or seminars, when we ask people whether did you notice this change, mostly it's very rare. Rarely noticed this particular change. So these are the oldest documents which was available for us to read. The IS 3043 first edition came in 1966. What you are seeing in the screen is the 1966 IS 3043. Earth was defined as a connection to the general mass of Earth by means of an Earth electrode. So wherever we say Earth, this definition was giving an idea that okay, you connect something to the you put an Earth electrode and connect to the Earth electrode. An object is said to be earthed when it is electrically connected to an earth electrode, and conductor is said to be solidly earthed when it is electrically connected to an earth electrode without intentional addition of resistance or impedance in the earth connection. So basically, the definition was in a typical fashion in the 1966 IS 3043. When it comes to 1987, the second edition of IS 3043, the definition was modified, and then the definition was redefined. You can see here the green highlighted portion, earth, the conductive mass of earth whose electric potential at any point is conventionally taken as zero. So this was a different type of definition. Here, in the previous one, it was told that you make a connection to the earth electrode in the soil. As a result, the energy immediately dissipated to the soil and you become safe. Whereas in 1987, it was redefined as the conductive earth means the conductive mass of earth whose electric potential at any point is conventionally taken as zero. Please note, conventionally taken as zero is very important now. In the second edition, 2018 of IS 3043, I don't know how many of you noted, there was no definition for Earth. The definition of Earth itself disappeared. This was only earthing system, global earthing system, and the Earth fault loop impedance. There were total change. However, because of these old definitions or the idea of connected to earth, and so that immediate discharge of energy, for example here the conductive mass of earth which was there in 1987 or 1966, the general mass of earth by means of an earth electrode, an object is said to be earthed. So these were the definitions which was predominantly used in our country. However, in the modern world, these are not really applicable. What I am showing you is from the electropedia. Electropedia is nothing but electrotechnical vocabulary. So all the terms and definitions nowadays globally is becoming uniform. In order to make it uniform, the global agencies, ISO, IEC, they have made this the electropedia, the electrotechnical vocabulary. So most of the standards are going or started using the global definition. Now, in this particular in the new definition of earth, you can see here, earth, verb, means it's not about the general mass of earth. It's a function to make electric, and you can also see earth, verb, and you can the ground, verb, US. In USA, the same name is not earth, it is ground. The meaning is to make an electric connection between a conductive part and a local earth. Here, the definition has totally changed. To make an electric connection between a conductive part and local earth. The meaning of local earth is local earth or local ground in America, part of earth that is in electric contact with an earth electrode and that has an electric potential not necessarily equal to zero. The previous idea was conventionally taken as zero, conveniently taken as zero, whereas in the new definition, the earth electrode need not have to be, the potential of earth electrode need not have to be, not necessarily equal to zero. Now, you see local earth. Let's say, for example, you are in a room. What is the local earth in the room? It is a bus bar, an earth bus bar or an earth terminal in your room. And that particular earth bus bar in your room, which is in electric contact, that is in electric contact with an earth electrode, need not be directly. Somehow the earth bus bar in your room is connected to an earth electrode and need not have to have a potential equal to zero. So basically, fundamentally, there is a big change in the definition in the recent years. Now, what has happened in our country was we were a little bit reluctant in changing our ideas. We were most of the cases, we still use the definition of the 1956 IE rule or 2010 the CEA regulations. As a result, what happened is whenever we talk about earthing, we were thinking about an earth electrode. Practically, what has happened because of this mistakes or misinterpretations in the definition? We have the habit of connecting two earth pit for neutral, two earth pit for body, two earth pit for the main distribution board, two earth pit for lift, two earth pit for UPS, two earth pit for one or two earth pit for electronics, and everywhere, all around the building, we started putting earth electrode. This was never ever written, or it is not scientific. It is never included or explained in any standard. However, a very, very wrong practice we started doing during probably last 30, 40 years. Every transformer, every DG, neutral means two separate earth pit, body, two separate earth pit, distribution board, two separate earth pit, lift, separate earth pit. This mistake was predominantly because of the definition, the mistakes in the definition, because it was defined that earth means general mass of earth and you have to make a connection to the earth for the immediate dissipation of energy. Now, this mistake, the second mistake is the concept of clean earth, power earth, lightning protection, separate. This is also a mistake. We have been advocating that. Please note that these mistakes are the main reason for non-operation of protective device during an earth fault, which is creating failures, fire accidents in the country. The third mistake, sometimes people are very much proud that I interconnected everything under the soil as a grid. This is also wrong. Earthing is not about putting too many earth pits or earth electrodes and connect everything to the earth electrode. As a result, what happens is you can see buildings with the earth farm all around the building, everywhere earth pit, earth pit, earth pit. And finally, and there is the practice of putting water into the earth electrode and so on. Predominantly, this was due to the mistakes or this was due to the old definition. However, in the new definition, earthing, the meaning of earthing, especially in a building, for example, protective equipotential bonding, as I read in the 2010 the 2020-23 CE regulation, the exposed conductive parts, extraneous conductive parts connected to the MET with the help of protective earthing, protective equipotential bonding, supplementary equipotential bonding, all the buried metal parts to the also bonded to the same equipotential bonding bar, which is the earthing conductor, and the MET is connected to the neutral of the source, which is called as means of earthing in a TN system. So in a TN system, legally we are supposed to follow TN system in India. The earthing is made in this typical fashion. This is defined in the CEA regulation 2023. It is also defined in the CEA regulation number 43, sub-regulation 5. I will show you this just in a minute. So fundamentally, there was a lot of change happened after 2020, especially in the CEA regulation as well as in the upcoming documents such as the NEC. Now the earthing in a building means you interconnect all the metal parts, conductive parts in your building, simultaneously accessible conductive parts in a building. As a result, there is no shock. It's a very simple idea. Potential do not create shock. Potential difference create a shock. So you bond all the conductive parts in your building. As a result, there is no shock. And the MET has to be connected back to the neutral of the source, which is called as the means of earthing. So here, what you can see here, I'm just writing the MET is connected to the neutral of the source. This is for a TN system. In case of a TT system, the MET is connected to the earth electrode in soil. However, TT systems are legally not recognized in the regulation because the regulation always say there should be an earth terminal, means a TN system. If you are using a TT system, practically which is applicable for low voltage electrical distribution in the or public electricity distribution, this is not applicable if you have your own transformer or if you have your own DG set. So you can also go for TT system. In case of a TT system, you can see here the exposed and extraneous conductive parts are connected to the MET, and the MET has to be connected to the earth electrode in soil, and this is called as means of earthing. Often, if you look at the standard, it's written metallic water supply pipes or gas pipes shall not be used as the sole means of earthing. The meaning is, in this particular in a TT system, now this earth electrode is the sole means of earthing. Means the entire fault current is supposed to flow through this particular the earth electrode in soil. Gas pipes shall not be used as a sole means of earthing. Means you should not use the gas pipe, buried gas pipe, so that the fault current is flowing through it. But of course, the metal pipe, you must bond it. So these changes basically had made predominant, very big changes in the entire system. As I'm just showing you the definition in the 2023 regulation. Earthing means connection of exposed conductive parts, exposed conductive and extraneous conductive parts of an installation to the earthing terminal of that particular installation. Now let me take you to the regulation number 43. Regulation number 43, earthing for low voltage up to 650 volt. What we should do, you can see here this highlighted part. Every building shall have protective equipotential bonding by interconnecting exposed and extraneous conductive parts as per the relevant standard. So here the relevant standard is IS 3043. If you go to the next regulation 50, which is earthing above 650 volt, connection with the earth for apparatus exceeding 650 volt. Now, see here, read here. The first requirement is limit the touch and step potential to tolerable value as per the standard. The idea is people should not get shock. You have to ensure that the touch and step voltages are within certain limit. As a result, people don't get shock. So now the new draft IS 3043, which is published on 25th of May, the last date is 25th of July, whereas this was published on 25th of May. So starting with the forward, sometime people try to read this highlighted portion and try to interpret it. This portion, it is from the 2018 IS 3043. As a matter of fact, the Earth now rarely serve as a part of the return circuit, but is being used mainly for fixing the voltage of the electrical energy system. This is the correct way. Normally, we think that the whole fault current goes through the earth electrode to the general mass of earth, then flow through the general mass of earth to the source, which was absolutely not correct. The amount of fault current, if it flows through the earth electrode, is negligible. It will be very, very low in comparison. For example, sometime there is an Excel calculation which is widely used in our country. Earth electrodes are designed for fault current dissipation 50 kiloampere for I'm saying for 230 volt application, 400 volt application, 50 kiloampere fault current, 25 kiloampere fault current, 30 kiloampere fault current. This is absolutely wrong. In actual scenario, the fault current in a low voltage system, let's say for a TT system, the current through the earth electrode maybe few amps, maybe 100 amps, 200 amps, 300 amps, never more than that. So 50 kiloampere current flowing through earth electrode, 25 kiloampere current flowing through earth electrode in a low voltage system, or even in a system up to 11 kV, 22, 33 kV. This is where these are not correct. So this time, a lot of improvement has been made in IS 3043. As you can see here, the code include comprehensive guidelines for earth fault protection in consumer premise. The rules given should be read in conjunction with IS 732 and IS IEC 614936. So here, IS 732 is for voltages up to 1000 volt AC, 1500 volt DC, and 61936 is for voltages beyond 1000 volt AC. Similarly, the code of practice has been updated based on the new definitions in the CEA regulation. In clause 4, there is a detailed explanation given which talks about the statutory requirements of earthing. Statutory means the legal requirements of earthing. Aligning the disconnection times, step and touch voltage as per the new standards. Color figure for easy understanding has been given. I just show an example of a color figure which is given. For example, clause number 9, generators, how to make earthing of a generator. You can see this particular figure. This figure was existing since 1987. Example of earthing in a generator and with an incoming electricity supply, manual or automatic changeover. You can see here the prime mover, the engine, and the alternator, the generator, the engine and the alternator body is connected to a common bus bar. Neutral is connected again through a link to the same common bus bar. The same common bus bar is used for extraneous connecting the extraneous conductive parts such as metal pipe, air conditioner duct, the rebar in the building, and so on. The incoming EB supply, the protective earth is also connected to the common bus bar. The load side protective earth is also to the common bus bar. The common bus bar is also connected to 5020 independent earth electrode, which is called as chassis earth. So basically, this picture was there since 40, 50 years, since 1966, I believe. But even with this picture, the idea of earthing for a DG, two separate pit for neutrals, two separate pit for body, this was followed, which was absolutely wrong. This picture is the correct way of earthing in a generator. The next picture, if you have multiple sources, if you have multiple DGs, now these pictures explains you how to do. There are three options here. Please note that everywhere the connections are made to a common earth bus bar, never to the earth pit, common earth bus bar. Multiple options are here. For example, the first one is with, you can see here, standby generator with the neutrals connected. All the neutrals are interconnected to a common bus bar and the neutral is connected to the earth through one link. The second one is earthed through a zigzag transformer. The third one is the third figure. The next figure is about neutrals earthed through a neutral switching contact. Color pictures are given, which is very, very clear. Now, please note that these are not new pictures. These are existing in the standard several decades. But instead of following this correct way, we were following in a different way. One of the reason was sometimes state electrical inspectorate engineers, they were demanding separate earth pit for neutral, separate earth pit for body. But however, as I said, these demands were due to the old definition in the CEA regulation, which is already updated in 2023. So the chance of misinterpretation of the definition or misinterpretation of the contents are already gone. Very clear definitions, very clear informations are already in the standard now. Coming to the definition of earth, which is adopted in the IS 3043, you can see here, earth means verb, electric connection between conductive part and local earth. Local earth has got again the definition, which is similar to the definition from the IEV, International Electrotechnical Vocabulary. Note the connection to local earth can be intentional, unintentional, or accidental, and can be permanent or temporary. Now, very interesting, you can see here the noun form of earth is mentioned as ground also in this document. For example, underground cables, UG cables, or underground connections. So, ground is also used somewhere in the standard, but the meaning of ground here is the actual soil, the actual ground, whereas earth means the connection of conductive part to the local earth. That is how it is. Similarly, the next improvements happened are misconcept of earthing explained in reference to IEC 61052 and IS 732. Misconcept of earthing. The misconcept of earthing, for example, as I explained you, everywhere we have the wrong idea of doing wrong earthing. Now this picture has been included. Separate. This is the figure 23. Misconcept of separate earth electrode. So if the electrical inspector or if any safety officer, safety auditor, or maybe factory inspector comes to you and asks for too many earth pits, you have to show this particular picture and tell them that, sir, this is wrong. This is the reason for all the accidents. You also can read the contents here, misconcept of earthing. The non-standard methods explained in 6.3.11 to 6.3.14 are misconceptions and shall not be followed. Shall not be followed means strictly you should not do. The source of these pictures are from a standard called IEC 61052. 61052 explained very clearly that, for example, here this particular picture, in the IEC it's written as this practice shall be prohibited. Prohibited in many countries. These are the wordings used. However, we have put this picture to ensure that the wrong things are at least stopped in the country. Example of such misconceptions are two separate earth electrode for each transformer, DG neutral, and two separate earth electrode for each transformer DG body, separate earth electrode for distribution board, lift, UPS. So absolutely this is wrong. This is very much included. Then, in an attempt to obtain clean earthing network, please note that these wordings are actually copied from the IEC 61052. Probably these wordings can be improved so that common man understand the words much better. For that, the people, those who are interested in the subject, are requested to download the standard, go through the standard, the draft standard, read the standard, and you are free to make comments, so that all your comments will be considered, or all the comments with your comments, probably you will be able to improve the document to a much better level. Similarly, the third picture, underground, this is also misconcept of earthing. These pictures were also there in IS 732. I am taking you to IS 732 2019. Let me scroll down. These pictures were there already in the standard. You can see here separate earth electrode and a cross mark. So these are not new pictures. These were there since several years, but we were not reading it probably practically. So then what is good? You can go to the next picture. A recommended configuration of earth electrode, earthing network, and an electrically insulated LPS. For example, inside the building, the power and communication, as you can see here, are bonded. So here, power and communication earth are bonded, as you can see here. Then you have the lightning down conductor. The lightning down conductor and the other earthing part in the building is only connected at the ground level. Since you made the connection at the ground level, the lightning protection is electrically independent or electrically insulated. In such case, you should, the LPS down conductor bonded to MET, separation distance as per 6.3 of ISIC 62305 shall be maintained. So you should keep the separation distance, means lightning protection shall be away, physically away from the building or other earthed metal parts of the building. So these are some of the changes which has happened. Now, for multi-storied buildings, if you cannot maintain separation distance, then the whole earthing, it looks like this one. You have to bond all the metal parts, including the lightning down conductor, from the top to the bottom of the building. So many equipotential bonding. The idea is there is no potential difference, there is no failure. So basically, in the new code of practice, this kind of misconceptions, which were already there in different standards, are being included, consolidated, and included, which is a very good information. The next improvement which is made is, for example, explanation of protective earthing from majorly used product standards. This was another, a misconcept or maybe a kind of a confusion between various stakeholders, especially example, the companies, those who are making lift, example, the companies, those who are, machineries, UPS, and so on. Information from those product standards are being included in this particular session. Now, let me just go through this particular session. Low voltage switchgear and control gear assemblies as per IEC 61, ISIC 61439. So here is the standard. The requirement from this particular standard has been included here. In case if you have a TT system, what the switchgear and control gear assembly should do. In case of TN system, what you should do, and what is the resistance required in case of a switchgear and control gear assembly. You can see here the resistance required is 0.1 ohm, about 100 milliohm within the panel. Next is UPS. What kind of earthing requirements are available or required for UPS? The source is IS 16242. The idea of including this information into the standard is, of course, these are repeating, but most often the equipment manufacturers try to make their own demands. As a result, the reliability of electrical installation is highly affected. So this is how the UPS has to be earthed. Big figure copied from the IS standard. You can read it. For machinery, again from the IS standard, IS 16504, how to earth machinery. There is a common earth bus bar. Now you can see here there is a common earth bus bar inside the machinery. All the metallic parts of the machinery are connected to the common bus bar. You can see here if there is an isolation transformer, the shield or the secondary side of the isolation transformer is also connected to the same common bus bar. Lift. A new picture has been made and put in the lift, but unfortunately, while the automatic numbering has been missed in the key, you have to read this as serial number 1234. So this was a small error which has happened. What do we do in case of a lift? This box, this dotted line, this is the lift panel. The lift panel is getting a supply from the mains The earth bus bar is connected to a common earth bus bar, serial number 2. This is the earth bus bar in the lift panel. Now, from this serial number 2, it goes to the, for example, the rail or the live parts. Then it goes to the car. Then it goes, for example, number 7, number 8. These are the protective devices such as 30 milliampere RCD, because the idea is the lift ISO IS 17900. It need a protective earthing. Fault protection is achieved by protective equipotential bonding and automatic disconnection of supply. In a TT system, sometimes you need to have an RCD for fault protection and an additional RCD. An additional RCD, 30 milliampere RCD for the car. The single phase supply has to have a separate RCD, 30 milliampere RCD. That means in a lift, sometimes you may have to have a 300 or 500 milliampere RCD for the main power panel and a 30 milliampere RCD for the lift panel in order to protect people from electric shock. So this is an information which has been included in the standard. Then we go to the next part. The different type of earth electrodes are being made. Please note that the two confusing information which we were carrying forward from the old standards, where the figures of the two earth plate and pipe. So let me show you these figures, how to put a plate and how to put a pipe earth electrode. These figures were actually creating a lot of confusion in the market, because the definition of the old standard says earth means connecting to the general mass of earth for immediate dissipation of electricity. And this particular figure gives an impression that every part of the installation you connect to the earth electrode. And that was a mistake the whole nation was following. So these two figures were, in fact, were creating a lot of confusion. Now these figures are being modified. The new figures, let me show you. The earth electrodes. The table, minimum size of earth electrode, this has been taken from IS 732 as well as the last year's NEC. Basically, the information is from IEC 60364, IEC 61936. All over the world, all the international standards are following this table as the minimum size of earth electrode, with the conditions of installation. If you have copper and if you have GI, what kind of problems can come. All these informations are being included. New calculations of earth electrode resistance. Please note that earth electrode resistance calculation to 2 digits or 3 digits, very accurate calculation, these are absolutely not necessary. And maintaining a very accurate earth electrode resistance throughout the year was also not possible. As written in the forward, the reliance to the earth for the fault return has been removed. The earth is nowadays used for fixing the voltage of the system. Earth electrode resistance is immaterial in this particular case. So simplified calculations are being included. These are from the IEC standard. You can see here, in case of a buried plate, how to calculate the earth electrode resistance. In case of a vertically buried electrode rod, how to calculate the earth electrode resistance. In case of a horizontally buried conductor, how to calculate the earth electrode resistance. And metallic pillars as earth electrode, how to calculate. So basically, new calculations are, please note that I will not say these are new calculations. These are improved calculations or simplified calculations made. Then the type of earth electrodes. What kind of earth electrodes can be used? The driven rod. Source of the figure is from IEC, ISIC 62305. Means a small piece of metals you can drive into the soil with. Number 2 is a copper conductor. So this copper conductor will be properly inside the soil. This becomes one type of earth electrode. The second type of earth electrode, again a driven rod. The third is again the same old information, the vertical rod in a borrowed or buried, in a hole, and the plate. Technically speaking, we have to be very careful in understanding these figures. Please note that these are typical arrangement of earthing or earth electrode. Sorry, not earthing. Typical arrangement of earth electrode. Typical arrangement means sometime you may have to make an earth electrode and you can use this method. That is the meaning. Similarly, concrete embedded foundation earth electrode, potential grading, all these figures are being made with respect to earth electrode. Now, just a moment. Now, let me. I wanted to hide floating panel. Okay. Now, going back to the index, what is earthing is also being included in clause number 7.2. Clause number 7.2 or 7.1, 7.2. 7.1 is equipment earthing. 7.2, earthing arrangement in a building. What kind of arrangements, how to do earthing in your building is the question here. Here there is a new picture included. You can also see similar picture in the National NEC 2023. This picture was there in the old IS standards, and this picture was also repeating. It was also available in the manuals such as CPWD manual, but we were very rarely looking into this picture and trying to make the correct method. Now here you can see here M stands for exposed conductive parts, C stands for extraneous conductive parts. You have an MET, you have a common earth bus bar. The exposed conductive parts are connected to the MET, extraneous conductive parts are connected to the MET. These connections can be made individually or in groups or collectively. Then you have the functional earthing, means the earthing of your electronic installations. You have a functional earth bus bar, and you should connect MET and the functional earth bus bar. In case of a TN system, you should connect the means of earthing is the neutral of the source. In case of a TT system, the means of earthing is to an earth electrode. All these explanations are being given in this particular clause. Similarly, very important information, global earthing system and modern method of substation earthing. We have been following some practices which was decade old. This time, a lot of modification has been made in this particular subject, the subject of earthing in substation. This is coming in chapter 10. Chapter 9 is talking about the earthing of generating plant, means generators, DGs, high voltage, low voltage DGs. Chapter 10 talks about earthing in power station and substations. So here the information are from IC 61936. Please note that this is the global standard. All over the globe, the same system has been used. We have a practice of using information from IEEE 80 more predominantly, but I don't know how many of you have really looked into what is IEEE 80 and what is the definition of IEEE 80. IEEE 80 is not a standard, it's a guide. According to IEEE website, IEEE 80 is not the correct information. It's an alternate information without conclusive result is the definition. I will show you later. Now, if we go to this particular figure, most important, you will be able to find out a table how to make earthing if you have an installation which is more than 1 kV. That means you have 11 kV supply or 33 kV supply, or maybe a transmission distribution substation or whatever, anything above 1 kV, how you should do. Data collection. The data to be collected are IF. IF is the total earth fault short circuit current. IE is the amount of the earth fault current which is flowing through the earth electrode. Please note that the earth fault current may be of the order of 50 kiloampere. But IE, which is the current going to flow through the earth electrode, may be of just a fraction of 50 kiloampere, maybe 500 amps or maybe 1 kiloampere, very, very small. TF is the disconnection time, and layout. of this entire installation. This is the first data which you need to collect. We have put a note 1. Note 1 gives you an information what exactly we are talking. Layout of all conductive parts in soil or embedded Layout of all conductive parts in soil or embedded in concrete, including building foundations, earth grid of substation, metallic piles, and other metallic installation in the vicinity of the plant, like metal pipes, rails, etc. So everything has to be considered while all the buried parts inside concrete, in soil, has to be considered while calculating this particular layout. Then initial design, functional requirements. Functional requirements, there are several functional requirements. One of the requirement is, in case of a fault in the high voltage system, the transferred potential to the low voltage system should be limited to certain value. Example, 1200 volt. More transfer potential to the low voltage system creates stress voltage in the low voltage installation and failure of electrical appliances equipment in the low voltage system. So functional requirements you should consider. Then we go to the global earthing system. Yes, design complete. Note 2. So if you are making global earthing system, then your job is done. Very simple. What exactly is global earthing system? I will show you in the definition. Now, if you cannot make a global earthing system is applicable for an electrical installation, which is a part of 11 kV supply or 22, 33 kV or GIS 166, 110, whatever. If it is a part of a building or if it's a part of an industry. So no global earthing system. Then you should do design of soil characteristics, means what is the soil resistivity, how many layers of soil are there. If you put earth electrode, if you put an earth grid, what kind of resistances are possible. Based on the resistance, you have to find out the IF, total fault current. IE is the earth current, the partial earth fault current which is flowing through the earth electrode. Then you determine the ZE, which is the impedance of the earth electrode, and you have to calculate UE is the earth potential rise. Generally, we also say GPR, ground potential rise, which is earth potential rise. Ground is not the word which we should use in India, so we have the UE, which is the earth potential rise. You can also take the help of note 3 and 4. Note 3, see table 29 for more details on IE. The current which is flowing through the earth electrode can be calculated based on this. And 4, 10.5.1 for more details on ZE. So you can find out more information about these two. Then the next step is determination of UTP. UTP is nothing but the prospective touch voltage. If the UE is lesser than UTP, yes, design complete. That means if the maximum earth potential rise is lesser than the allowed touch potential, your design is complete because you don't get a shock. That is the idea. If the UE is higher than UTP, then you have to apply the additional safety measures, which is also explained in note 7 and 8. Then you should determine UT, which is the touch voltage, determination of UVT, prospective touch voltage, and prospective UVTP you should calculate. Then you should make a comparison and finally decide whether to improve the earth electrode layout or you are happy where all the calculations are within this limit. Now, in order to achieve this, one of the important subject which we should consider is there in the clause 5. Clause 5 is very important. Example, the calculation of permissible touch voltage. Please note that in the new standard, there will be a lot of new terms, permissible touch voltage, prospective permissible touch voltage, and so on. So this is the method to calculate the permissible touch voltage, which is, you can also see the information in IEC 60479 as well as IS 732. Then finally, you have a graph like this. So this is the permissible touch voltage with respect to time. You can see here time, the duration of the fault disconnection time as well as the fault voltage. Now there is a graph So always the idea is the touch voltage has to be lesser than this within the tolerable limit. Means if the disconnection time is 100 millisecond, then the maximum allowed potential is, let's say, something about 750. If the disconnection time is something about 1 second, maybe the voltage is something about 100 volt. So from this particular table, you can very easily calculate, you can very easily find out the permissible touch voltage. Or you can also calculate it based on the formula which is provided based on different conditions. You can read the key of these figures, then you can understand very well. Prospective permissible touch voltage. This means imagine an electrical installation where the touch voltage is 115 volt for 1 second, and you are not able to reduce the touch voltage lesser than 115 volt. Under that condition, one of the method which can be adopted is you allow people, only skilled people has to be allowed in this particular substation, and the people always should have PPEs like shoes, like gloves, and so on. Now the prospective permissible touch voltage based on the additional resistances offered by the gloves, offered by the shoes, offered by the resistance of the gravel can be calculated based on this. Please note that these informations were already existing in ISIC 61936. So when you read clause 10, you also should read together with clause 5.2. The prospective permissible touch voltages are given here. Let's say, for example, 1 second tripping time, the permissible touch voltage is 104 volt. Then the permissible touch voltage with additional resistance, let's say with gloves or with shoes, 1 second disconnection, in a typical case 160 volt or 420 volt, you can find out. You see the conditions are given here. Similarly, step voltage is the body factor, the heart factor considered in case of a touch voltage. When you touch an exposed conductive live conductor or an exposed conductive part, a faulty conductive part, or a touch potential with your left hand, or the heart factor considering a current flow through the left hand to the feet is considered as heart factor 1, and the heart factor considered is 0.04 for step potential. So these are the some of the informations which is included. Just a moment, please. My computer has got a small issue. There is a small power cut. As a result, what happens is the suddenly. Yeah, let me share. Just hold on, please. Yes, my computer has started. Yeah. Thank you. Thank you for the patience. Now, this information, the step potentials are also given. Say, for example, the step potential in case of 1 second is 3450, and with additional shoes, additional gloves, you can achieve much higher potentials. These informations are given in the particular table. So chapter 10 is a very important table. I request you please go through the table. You will have a lot of information in this particular table. Then clause 11 onwards, additional informations. Let me go to the information. See here, further improvement. Measures of touch and step voltage and continuity resistance measurements are being included. Earthing of specific applications such as industrial and commercial premises, medical establishments, solar PV and data centers are included. This is in clause number 11. Let me show you clause number 11. Clause number 11, examples of typical building. Please note that these figures are not invented by the committee as a new. These were already existing. This is the typical method of earthing in case if you have a transformer. You see, you have the source, you have the installation, you have the transformer. The body of the you have a MET, a common bus bar. Body of the transformer is connected to the MET, maybe two connections. Neutral of the transformer is connected to the MET. Then you have the PE conductor, which goes to the exposed conductive parts of your installation. Additionally, you can also connect it to a grid. So this is one of the information. Then you will have multiple pictures to simplify the subject. Please note that the standard giving so much information as pictures is quite rare nowadays. The method of standard is always to write what is required. We made a lot of figures because the subject was so much confusing to the market, especially the disease of 2 for neutral, 2 for body. This was killing all our electrical installation. Now these figures are not the inventions, new inventions. These were there in multiple standards. Example, this figure, what you are seeing, is typical example of earthing arrangement. This was a part of ISIC 62305. And this figure was also a part of ISIC 62305. So different kind of figures from different standards are being included. Say, for example, you have a substation building, something like this. This is the substation building, and how to make earthing in this particular case is being included here. Just a moment, I'm facing a little bit trouble with respect to electricity. 2 times it went and came back. Okay, now this is in one case. Similarly, if you have a substation building separate from your industrial building, and if you are putting the transformers within your main industrial building, these are the conditions of earthing. You can refer these figures. Similarly, for medical installation, hospitals, how to make earthing, you have the common earth bus bar. All the metal parts are connected to the common bus bar. Please note that this figure is from National Electrical Code 2011. So then you have the common earth bus bar. It is running all around. All the metallic installations are connected to the common bus bar. Basically, the standard very clearly tells you that good earthing means you are making a perfect equipotential bonding. If your equipotential bonding is better and better, you have a very good earthing. Similarly, for medical locations like group 1 and group 2 locations, the additional informations are given in this particular figure. The source is again from NEC 2011. Similarly, for solar PV, you can see here the figure 81. You see, so many figures are being included in this particular standard. Solar PV, again a confusing subject. Several of our documents say DC side separate earth pit, AC side separate earth pit, lightning protection separate earth pit. Like this, it's so much confusing. So much mistakes are being followed. This figure is again from an IS standard, which tells you, as you can see here, there is a common earth bus bar. So all the metallic parts, exposed and extraneous conductive parts, are connected to the common earth bus bar. This also explains where to use the SPD and so on. Two type of connections are shown. One is for a TNS system, and next one is for a TT system. So both the figures are included. The system remains same. Every metal part is connected to a common bus bar. Similarly, how to earth in case of floor-mounted solar PV installation. So this is the additional information. Similarly, the next chapters, chapter 12, talks about the maintenance of earthing arrangement and earth electrode. Maintenance of earthing arrangement and earth electrode. Here, you can find out some information, how to maintain earth electrode, how to maintain, the protective equipotential bonding. Then going to clause number 13, which talks about measurement of soil resistivity and earth electrode. As I said, the reliance on soil for the purpose of fault return is very much less nowadays, but still still the old calculations are still following. But a lot of improvements happened in this particular chapter. The new figures from the IC 60364 are being included, especially to measure the earth electrode resistance. Please note that earth electrode resistance measurement is not necessary always. It may be required in case if you go for a type A earth electrode for a lightning protection system. In other cases, it's not mandatory. However, the figures are included. The earth electrode resistance using current clamps are being included with pictures. The earth electrode resistance, earth electrode resistance with the help of a fault loop impedance meter has been included. Then the measurement of resistance and impedance to earth. This is based on high current injection method. You have a current injection test kit, and you are injecting a current, and you are trying to find out the touch and step potential. These figures are included, informations are included. Then the method, how to measure the prospective touch voltage, UVT with additional resistances are being included. Continuity resistance measurement, for example, in case of a lightning protection system, you need to measure the continuity resistance, and that is included. Continuity measurement in case of a protective earthing in a building. Example, imagine you have a panel board. This is the panel board. And then you have a common bus bar in your industry. And now you are making a protective earthing, nothing but you take a wire and interconnect. Now the reliability of this connection is ensured by certain calculation and certain measurement that is included. Similarly, as informative for the information of users, multiple sources. These are information from the upcoming standards, future standards. In future standards, the practice of using neutral earthing outside is getting reduced nowadays. The best practice is to make the neutral earthing inside the main distribution board, as you can see here, number 6. So the name of neutral earthing is being slowly changing to system referencing. And system referencing means neutral earthing. The best place to make the neutral earthing is inside the main distribution board. Those informations are given here, but it may take some time for the market to learn and do it. But this is the best method. These informations are included in the standard. Then earthing and bonding in and EMC in building, some small informations are being given. Portable equipment for earthing or earthing and short circuiting for live working. If you have a live line, how to make the earthing of the overhead conductors before making, before jumping or before making a maintenance. These informations are taken from the IS standard are being included. Maximum allowed resistance, please note it's normative, it's not informative. Maximum allowed resistance of conductors for protective earthing is being included. Protective earthing and protective bonding is included. Then calculation of earth fault loop impedance as a informative information is given. Just this particular picture explains you what exactly is earth fault loop impedance. Please note that earth fault loop impedance measurement is mandatory. It has been included in the CEA regulation as well. So here there is an earth fault. The fault current goes back through the PET, through the metallic fault return path, and in a TN system, this is the earth fault loop, and the impedance of the loop decide the amount of the earth fault current, and the amount of earth fault current decide the tripping time. In case of a TT system, here you can see the fault current goes through the earth electrode through the general mass of earth and returns back to the source. So these figures are being included. Then a detailed calculation as an example is being included, because once when you calculate the fault loop impedance, you have to consider the impedance, the resistance and reactance of large conductors. The bigger size conductors, you should consider the resistance and reactance. An example is being given, a detailed example is being given. Then the last information is a shared PE conductor. For example, if you have multiple runs of cable going to one part of the electrical or routed through one part of the electrical installation, you don't need to run multiple P protective earth conductors. You can run one protective earth conductor. Now that information is being given in this particular annex. So basically, the IS 3043, this time it has come with a lot of revision, and these revisions are very much updated with the latest and the modern standards. So please note that a country like ours cannot run with always using earth pits in soil, chemical earth, digital earth, and all these foolish ideas. So everything has been modified in this particular document. We request you to go through the document, read the document, and probably um, if you make a comment, would be very good. Then one more information which would be informative, which is required, is the usage of earth enhancing compound. Earth enhancing compounds are being used widely in the country, thinking that these magic compounds produce a lot of info, or it gives a lot of solution to you. But the new method of earth enhancing compound, just a moment, let me share it. Condition, allowed cross-sectional area, effect of moisture, earth enhancing compound. So there is a chapter. We search it. Earth enhancing compound. Yeah, artificial treatment of soil. Very, very good and accurate information. Artificial treatment of soil. Multiple rods, even in large number, may sometimes fail to produce an adequate low resistance to earth. Please note that you don't need a low resistance earth electrode. That is point number one. Except 10 ohm for a type A earth electrode in case of lightning protection. This condition arises in installation involving soil of resistivity above 3000 ohm meter. That means if the soil resistivity is below 3000 ohm meter, you don't need this particular thing. Treatment of soil by using earth enhancing compound to improve earth electrode resistance should be applied in locations where the soil resistivity is higher than 3000 ohm meter. That means if the soil resistivity is lower than 3000 ohm meter, you should not use earth enhancing compound, because in soil with resistivity lesser than 200 ohm meter, compounds used for artificial treatment of soil are not effective, hence shall not be used. In soil with low resistivity, increased corrosion of earth electrode and other buried steel metal in and around the area should be considered where these compounds are used. In general, use of such compounds are discouraged. So basically, we are not supposed to use this earth enhancing compound or this particular chemical. Please note that this information is not new in the IS standard. It's already there in the IS IEC 62305 standard. This information is only reproduced. And for example, there is a new standard for earth enhancing compound, which is IS 18925 part 7. This information which I have shown, the 3000 more than 3000 ohm meter, or it should not be used lesser than 3000. These are already there in the IS 18925 part 7 of the standard. So basically, this time the IS 3043 has come out with a lot of modifications, lot of improvements, which are going to create substantial changes in the way we install or we make electrical installation or we calculate earth fault in the electrical installation. And all these changes together are really going to make a lot of improvement in our electrical installation. So with this, I would like to stop the presentation. Then probably we can have a question answer. And we thank all of you for the participation. Today we have a record participation. Probably since the participants are more than our capacity, probably if you are routed to the YouTube link. I would also request you to put the questions in the Q&A. please avoid questions like whether earthing and grounding is correct. Earthing is what grounding is. All these things are too elementary. In the sense, if somebody says that grounding is for neutral of the transformer and earthing is for equipment of this is too elementary. This is for nursery school children. Try to work like an electrical engineer. Don't try to ask so silly questions. You can very much read in these information in the standard. I'm so sorry to make this comment because whenever we make a webinar seriously with a serious subject, at the end of the day, questions will come. How many earth pits are required? What is the earth electrode resistance required? So these are too elementary. So over to you, Dominic, sir. You are there.
I understand, but my concern is that
Yeah, I
so
voice
looking
is
at Navi,
yeah.
when questions popping. Can you hear me, sir?
I can hear you, but the question is, your voice is still very bad.
You're
I
not
have put taken Apu sir also into the line. Apu sir, are you
Also
able
can hear the
Yes,
Mr.
sir.
Dominic, probably you can keep silent. We will handle because your sound is too bad.
Uh, Good
Yes.
morning, sir.
Good morning, sir. So
Good morning,
today
sir.
is very important
Am I,
webinar, sir.
okay. Am I audible,
You are
sir?
on.
Am I audible? Yeah.
Yeah, you are on.
It's a very good compilation of the ongoing exercise and feedback from the general public with reference to the evolving 3043. Actually, in high voltage substation design, you have brought, in general, you have brought out all the development that happened in this by bringing the standard. There were conflicts. Previously, there were conflicts between the standards. So there were conflicts between 3043 and IS 61936, and there were conflicts between the standards and regulations. So all such conflicts have been removed now. Now a synergy is achieved for the first time. Nobody can refute because it's based on internationally accepted norms and basic science. So there can't be any difference of opinion. For example, certain areas I can say the fault current in HV substation thing only I am touching upon. The fault current, duration, soil resistivity, and yard dimension. This is major data that you have to collect. And other things are the nature because, for example, the body current is based on the voltage and the body resistance, which varies with reference to the voltage. These are the new, not the new concept. These were the concept to be adapted. Unfortunately, we have been adapting IEEE 80, where a straight formula 0.116 divided by square root of 3. That's a single fundamental first step. So that has been rejected by the IEC. And IEC has evolved the heart factor, body impedance for applicable touch voltage. These are the things that is based on the natural nature and science. And in IEEE 80, mesh potential was arrived. Now it is not considered by the IEC. In IEC, touch voltage, and at the final step, there is a conventional touch potential. At the worst case scenario, if the fault current and the duration and your soil resistivity, these are all not conducive to arrive at a safe touch potential. You have to go for the conventional touch potential, UVTP. But the whole exercise of the standard is to rely, there is a much reliance on validation by test. The UVTP is also ascertained by field test, by high current injection. So fundamentally, we are thinking that the earth current goes and vanish. It doesn't. All the earth current, as GK observed, all the fault current doesn't go into the general mass of Earth. A certain portion gets divided into the grid current division through the overhead screen conductors and general underground earth materials like rails, pipelines, etc. And a partial thing, and also the neutral of the transformer. So the partial current is flowing, maybe 25 to 50% maximum. So here we have to consider the grid current division. So all the earth potential rise is not becoming the factor. There's a grid current division, there's a potential grading. Finally, in HV subtraction earthing also, the disposition of earth electrode is more important than providing the number of earth electrodes. For example, in a 110 kV substation with a fault current of 15,000 kilo amps, the actually there could be a yard dimension of 175 to 100 meter. Here, you can provide 50 earth electrodes. You can achieve the earth resistance to the value of 0.202 something. But if you increase the earth electrodes to 100 numbers, nothing will be observed. Only 0.0001%, 1 ohm only will be it will be reduced. So it's not the earth resistance standalone factor, even in HV insulation. Earth electrode is one of the factors, one among the factors that we have to take into consideration. Disposition of earth electrode is more important. And these things are given very good. There is a very good introspection in this 3043 revision where you have to work out and there should be a paradigm shift. So far, we have been going in a lighter vein, how to address these issues and how to arrive the tolerable, safe value of limits for the operation of equipment as well as person in the substation area. Now things have improved, everything is transparently given, and but start with it will be difficult for us to cope up because we have been trained like that. But it is not difficult to follow the new concepts where we are taming the natural body factor, body impedance, heart factor, everything, with reference to the mitigation of another factors, that is from fault current, duration, soil resistivity, yard dimension, so many factors. How these are beautifully woven in the standard is important. Hope our consultants and our designers are making use of these. And one
Yes.
step have gone ahead. In European standard, they have put something. We have adapted certain things, corrected certain things to the Indian standards. With this, I hope that we can go with the next level for substation design. Thank you,
So
sir.
we have a lot of questions. We have, I think, about
Oh,
60, 70 questions.
oh, fine. We can deal, sir.
So many questions. Here, a lot of questions are, not a question. These are like statements. Somebody saying that can we make TT system for high-rise tower? Then somebody asking what is TN system, what is TT system? Such questions probably we just neglect. Request participants, please download the standard. Probably Lakshmi, can you put the link for downloading the standard in the chat box so that people can download it and download and
Okay.
please read and comment it, please. So we would like to take a few of the questions, but the important point is the questions. There are so many questions. Finding out few questions is sometimes quite difficult. Somebody is saying, does this mean we don't need to provide two independent earth connection to transformer or generator? If you say this, if the person who asked the question is thinking about two independent earth connection to two independent separate earth electrode, then you are right. You don't need to give. It is wrong, is what we explained. Apav sir, are you able to see few of the questions?
Yes, yes, I'm able to hear your voice. I'm not able to see the QA box, but however, I can answer whatever the question.
Okay. Mr. Ajit is asking whether equipotential bonding create problems like component failure and healthy equipment during earth fault or lightning strike. Mr. Ajit, no. If the equipotential bonding is perfect and if it is made as per the recommendation of the standard, absolutely your equipment will have long life. The chance of failure is absolutely nil. Someone asked, what is TNTT? Please define TNTT, TNC connections, earthing, please. Gentlemen, we have made a lot of seminars, webinars, and the videos are available in the YouTube. For more detailed explanation of TNTT system, please go through our YouTube videos. You will be able to find out a lot of information. What is the correct value of testing of earthing system is one question. I don't understand what exactly it is. What is the correct value of testing of earthing system? Sorry, the question is not clear. Probably if any of the attendees wanted to ask a question live, we can allow you to talk. So Mr. Rajesh Aire has raised the hand. Please, you can ask the question, Mr. Rajesh. Also, Mr. Amit, Amrit, Mr. Sebastian. Parallelly, let's take.
Yeah, am I audible?
Yes, make it quick, please. There is big background voice.
Yeah, I am also not able to clearly hear. My question is while making the definitions, I find now the definitions of Earth, reference Earth, and similar words are newly introduced or the definitions are changed. Now, if you refer IS 732, you get a different type of references. So this will go on for without any conclusion. So is it better to have a proper document like IEV?
Yeah, you see now all the documents are going towards IEV. Maybe it's a question of time. Once when all the documents are updated, everything will be going towards the IEV. Not only the Indian standard, I think all over the globe, all the standards will be adopting the same definitions. You see, these definitions they are not conflicting. It is the misunderstanding which is creating the conflict. Otherwise, definitions are clear. It only depends how you understand the definition. Thank you very much, Mr. Amrit. Mr. Rajesh, you have any question? Also, Mr. Sibin Sebastian. Also, Mr. Vaibhav Desai. Mr. Santosh Gaikwad. There are about 70, 78 questions still. I'm trying to take few of the questions. Ravichandran Krishnaswamy, I think in the draft, the neutral is shown as earth transformer in the lower solar inverter. However, this configuration is generally not compatible with most inverter models, as it may lead to tripping. Kindly reconfirm and let us discuss this. Mr. Ravichandran, instead of discussing this, this document is for public comment. Please make your comments. Please make your comments in the to BIS, and all the comments will be discussed, and it has to be considered. It will be considered by the committee. I request you to make the comments. So, Mr. Santosh.
Yes, please. Yes.
Yeah.
I just wanted to ask the breaker manufacturers like EBV or Schneider, would they modify their fault current level if the fault current is not that much? Would they modify to the lower limits? Like now they are manufacturing at the level of 50 kiloampere and 75 kiloampere, and we are paying a high price for these things. If fault current, as you said, is not that much, then would they manufacture the things, their breakers?
See, there is a misunderstanding here about the fault current. When we talk fault current, this is about earth fault current. Whereas the fault levels of the switchgear which we are talking, they are also supposed to handle the short circuit current between the live conductors, which is totally a different subject. So 50 kiloamperes, maybe 40, 50, 60 kiloampere, these are often the short circuit currents between live conductors. which has to be calculated based on the requirements of the, there are standards to calculate, and based on those calculations, you may have to size the protective gear. What is what can significantly influence is now circuit breakers, for example, there is a habit of using LSIG circuit breakers. Out of this LSIG, the G stands for maybe 20% of the rated current, which is for the earth fault protection, the G part I'm saying. With the new concept in a TN system, with the introduction of earth fault loop impedance, circuit breakers with G may not be required, because the whole concept is different. Because in a TN system, you must ensure that there is enough earth fault current to disconnect the protective gear within the time stipulated. As a result, probably the use of bigger breakers with LSIG, the G part may not be required. That means the ground fault part may not be required. Thank you. Maybe some other question from any other participants. So then there are, Apav sir, you would like to take any questions? I think there are so many participants from outside India.
Yeah. I think there is one question from Deepak Goswami. The question is, in switchyard project 33 kV bar 66 kV bar 132 kV, can I have considered the earthing pits in less and we can connected via equipotential bars? Just example given in LPS, UPS, etc. Shall I go through the same procedure as considered for the switchyard projects? For which I would like to answer. Mr. Deepak Goswami, the logic is okay. Lightning protection system and EPS, here you are providing some equipotential station. But as far as SV substation is concerned, equipotential station automatically occurs because of grid and the earth electrodes. Here the potential gradient, see, you can achieve in certain installations if the soil resistivity is very low and the fault current is very low, then you will be easily satisfying. But there are some challenging areas where the soil resistivity will be very high in the order of 1000 ohm meter, or the fault current will also be very high. In those areas, you can achieve by test by considering the UVTP, that is GK has observed UVTP, that is conventional touch potential limit. There is a flow chart. You can go through those flow chart and adjust one by one. Finally, you will be coming to the UVTP. That's a final step. That step should be in all the mitigations. Everything should be validated by test. This is the important subject in the standard for HV substitution. This thing, not only HV substitution, everywhere. Even in LV substitution, you have to validate by a fault loop impedance testing. So as far as HV substitution is concerned, this final onerous condition is the thing that I already explained, for which you have to mitigate the reduction of the dangerous potential through surface layer and PPEs, including gloves and shoes, and also the potential grading by positioning earth electrode nearer to the equipment 1 meter away, because you are going to touch the any metallic part 1 meter away. So in short, if you visualize these concepts through detailed worksheets, you can have an idea that the earth electrodes can be positioned along the equipment and along the switchyard operating positions. So these are the things that you have to mitigate. Finally, you should be validated by testing alone. So I have explained from the fundamental easily achievable level to the highest level. These are all explained in the flow chart and the 3043 new standards. So this is what I can expect you. Thank you, sir. Thank you, GK, sir.
Sir, some of the questions are somebody is saying that about IEEE 80 as well as about the earth electrode, one earth electrode is enough for all those questions. You are, all the exposed extraneous conductive parts are connected, and there is only one earth electrode which is danger is the question. Now, for that particular question, I just put the, I'm showing on the screen, you are seeing IS 732 clause 5.4.1. You see here, there is a note. An installation does not need to have its own earth electrode. IS 732 is talking about protection from electric shock, protection from thermal effect, protection from overcurrent, and protection from voltage disturbances. And for those purposes, especially in a TN system, the note is applicable. An installation does not need to have its own earth electrode. Means this is the source of this information is from IC 603645554. That means your installation will work even if there is no earth electrode is the meaning. Now regarding the second question about IEEE, I'm just showing you the IEEE standards board operation manual. You can also find this information. 1.2 IEEE standards include but are not limited to, blah, blah, blah. Now, you see, IEEE standards are classified as standards, document with mandatory requirement, recommended practice, documents with, let me zoom it, a recommended practice, documents in which procedures and positions preferred by the IEEE are presented, guide, documents in which alternative approach to good practices are suggested but not clear-cut recommendations are made. Please read it carefully. IEEE 80 is a guide for substation grounding. The definition for guide in the IEEE website, let me zoom it again. Guide, documents in which alternative approach, that means this is the correct approach, this is the alternative approach to good practice. So there is a good practice and correct method already available. Guide is giving a alternate approach. If you want, you can use this alternate method, are suggested, but no clear-cut recommendations are made. In the other sense, the ISIC 61936 is giving you very clear-cut picture what you should do for a substation earthing. So using this IEEE 80, be careful. Of course, a lot of very, very highly useful information are there in IEEE 80. We also make use of it quite often, but please read the correct meaning and use it. Thank you very much. If any of the participants would like to ask a
Sir,
question.
I have one question.
Yes, please.
Just one question. It is not directly related to electrical earth, but there are one practice going on in factory that people are replacing their electrical mats with dielectric coating, and they are saying it is okay, we can do it. So I have opposed because there is no standard for testing of that dielectric coating, and we don't know when it get puncture and when the value will down. But I'm not getting any document by which I can oppose. So I just want your inputs.
Sir, can you repeat the question? I'm sorry, I didn't
Yes,
understood.
yes. No, not an issue. Not an issue, sir. Uh, the electrical mat used for panels. Okay.
Yeah, the rubber mat. The rubber mat.
Yes, rubber mat. Yes, people are replacing those mat via dielectric coating.
Okay, a kind of a paint.
Yes, paint, and they are saying it is a similar kind of thing, and we can do it. There is no issue in electrical system. Is it
Very
okay?
simple. If this is accepted, then there will be a standard. If there is no standard, it means this method is not accepted. So you can very well ask the supplier, show me the standard where this is explained, where the dielectric testing is made.
Don't mind, sir, but there are some electrical inspectors. There are factories like ITC, Tata, Nestle, Perpetti. They are doing this kind of thing, and people are forcing us to do it. I just asked, give me document. They are showing us CPRI report that we have tested. It is it have good insulation. Then I told them paper also have good insulation. Can I use paper in place of rubber mat? Don't. But I am not able to find out right question or right document by which I can stop this. So I need your support, sir, in that.
I think, sir, these names which you have mentioned, probably they are not bothered about the safety of their people. If you are bothered about the safety of your people, better is to use the correct method which is recommended in the standard. Any modern or
Sir,
probably, in films and videos, we see ghost where their leg will not touch the earth. Maybe these factories, the people are working without touching the soil. Maybe they can do whatever. Sorry to say this comment. If something is not
No,
written in the standard, better to avoid.
so,
Thank you.
so what to your opinion, sir? Is it right or wrong?
sir, I can put it in another words, Mr. GK. See, insulating mat is a product standard. It is approved in BAS. As GK said, you just ask what is a product standard for this. We can't rely upon the test certificate issued by any laboratory for which the product itself is not a standard evolved so far. CPRA can have issued the test certificate for as per customer specification, customer requirement. Any laboratory will issue certificate as per customer
Agreed, sir.
requirement. It doesn't mean that this requirement, it is a marketing gimmick, I can say. You obtain
Agreed, sir.
one test certificate and want to convince all the engineers who are ignorant on these basic ideas. Actually, this is the thing where the person, operator, is working in a confined area, is standing on the insulating mat to avoid the touch potential, where we are sacrificing. Can we expect this paint which have been provided? It may exhibit a good thing initially. What is the sustainability of this paint getting penetrated by a pin or something, the dial sprinkler? These are all unnecessary for us to go and invent the reveal. We already have an accountability. As an engineer, you have the accountability. If something goes wrong, then the engineer in charge will be made accountable. The court judgment as well as the act is clear. They
Sir,
fix
sir,
accountability.
sir, they are showing CA document, the Central Electricity Authority document, where it is mentioned
Nobody will come
electrical
to your
mat.
rescue. Nobody will come to your rescue. Finally, you will be played as a scapegoat. You put your management that I
Mr.
can't be
Singh,
scapegoat.
Mr. Singh,
Then ask someone
you
to
see,
take the responsibility.
yeah, Mr. Singh, if you have these
Yes, sir.
documents, why don't you share with us so that we can make an
Sir,
investigation
can
taken? You see, a few months
100%,
back,
sir. That is what I have posted on LinkedIn also to you. I need this support from you because I saw many things from your company. So just share your mail ID, sir. I will share everything what is
uh,
going on and how
you
we
can.
can do.
You see, the members of NFE are asking some such questions. So, for example, somebody came out with an idea of, somebody asked whether the IoT-based device, CNABL tested IoT-based device, and we investigated it, and finally we found out that this NABL testing, the claim of NABL testing itself is fraudulent, and we have published the technical articles. As a result, now everybody knows that this IoT-based electrical safety measures are not the correct way. We can publish it, but we need the entire documents from you. You can find our in NFE website. You can find the email addresses. Please send the
The
details to us.
secretary at nfec.org, right?
Yeah, nfes.org. You can send it, and we
Okay,
will
sir.
take it. Thank you. Thank you
What
very
I
much.
will do, I will ask company to share all documents and I will share with you what
Yeah,
they are
yeah. You
proposing.
please discuss with the document. Without the document, we may not be able to further take it. Thank you very much.
Okay.
We have
Okay. Thank you, sir.
other people also. Mr. Yogesh, if you have any question.
Yes, sir. Yes, sir. So, through this equipotential bonding, okay, so our earthing is also getting connected, and also the equipment earthing also getting connected to the common this one earthing phase strip. So, in case of any leakage or faults in the neutral, so does that current goes to through the equipment and impact the people working on the equipment through so any shocks or something like that? So, don't you think, sir, it will impact the people and equipments also? Working on there?
No, no. In the annex F, there is the fault loop impedance. The circuit is given. Please have a look on that. If there is a leakage or if there is a fault on one circuit, the route of the fault current flow has been shown. Nothing. It won't harm your neighboring equipment, as well as it won't create shock hazard to people. This is the safest, and this is the method. You
Okay.
please have a look at that. Also, you
Thank
can
you.
please make comments on the standard.
Sure,
So
sir.
thank you,
Thank you.
Mr. Subrata Kumar Bera. If you have any questions, you can start. If there is as I said, there are so many questions, about 70, 80 questions are there. It will be very difficult to take up all the questions because most of the questions are too elementary. So if there is, so as a result, probably we may not take up the questions today. Mr. Dominic is also not available. And if there is no other questions for the participants, probably we can finish the webinar. We will come back with one more webinar on the subject, maybe next 2 or 3 weeks, so that you will be able to get more information. So, Apav sir, you would like to make any conclusive?
Yes. There is one question, final question I'm seeing now from Mr. Vinesh PV. He asked, in case of HV side fault to body of transformer, fault current are mainly capacitive unbalanced currents between here. These currents has to flow through the earth electrodes. Then lower resistance earth electrodes may be required. What's your take on this? Sir, this is clearly addressed. There is a potential being transferred for the fault in HV side. That is getting transferred to the LV side, LV insulation, and impress a stress voltage on the equipment and a touch voltage on the personnel. There are clear guidelines issued for this specific subject. This is a transfer potential that can affect how to mitigate. Here also the equipotential is becoming the role. The resistance, earth electrode resistance can be done, addressed in the HV substation where you have lot of yard area. You can do a lot of things. More importantly, we take the by mistake we are assuming values for duration and the fault current. We have to assign the fault current. For duration, the CEA grid standard regulation 2010 has clearly provided the maximum fault clearance duration. For example, 220 and 130 kV, you should not exceed 160 milliseconds. Around 400 and 765 kV, it should not exceed 100. But what we are seeing in all the calculations is 0.5 second. So important areas, we are assuming things and going against the standards. Here, in this standard, it is everything clearly given. So in the screen, you can see what are the different, what are the different misconceptions that we are having. The screen, you can see how the HV side fault is getting transferred to the LV side because of HV side earth fault. And the ways are also available there, how to mitigate. The ways are, the LV side, you can either go for TN or TT system. HV side, either you can separate or connect. The worst case scenario is when the equipments are connected. When the equipments are connected, if you have a TT system, then the potential rise will be high in your equipment. That is under column 5. Under column 5, there is a TT system. You have, you have the body and the neutral earth connection of the transformer connect. This is worst case scenario. Another worst case scenario is TN system where again the connection is there, interconnection is there, you will have a touch voltage. How to achieve the U2, the voltage U2 with the TT can be easily achieved. So you have no other alternative. You have to go for TN system and achieve the values within the limit by equipotential only. You can't go on reducing earth electrode in a given yard dimension. For example, in your consumer area, you will be having 10 to 20 meter square meter yard only. So you can't bring down the earth value below 0.2 or 0.5 ohms in a 100 ohm meter soil resistivity. You can't also have insist your client, your owner or your builder to have a 200 by 100 meter. Within the area available, you have to assess all the mitigations and provide a end result, which is practically having a optimum result. So there are clear guidelines. You please go through those calculation
Yes.
part and
Clause
you
number
can
5.
yes.
Please, Mr. Anish, please go through clause number 5.3, which is very much explained. So then, sir, Mr. Deepak Goswami, in equipotential bar, shall I consider the differ size of earthing strip in loop or loop out process? Mr. Deepak, this is also available in clause number 6.3. There were some pictures. How to make these connections are also given. Please go through it. So with this, probably we can finish. What is your opinion, sir? Apov, sir?
Yes, sir. Yes, I think we can. We are conducting so many webinars and seminars and workshops. So it will be better if people are getting a direct attendance at the workshops that is being conducted across the country. So for 41 have been conducted, and the near future, next 20 webinars we are going to, seminars we are going to conduct. I request all the participants to get a direct interaction so that the doubts can be clearly cleared by from the faculties and the experts. We can also learn from them. Thank you. This is my observation, Mr. G. You can conclude.
So, participants, please note that this month, June, we have 3 programs. The first program is on 25th June at Udaipur. It's a one-day seminar on all these subjects which we are talking. 26th is at Delhi, and 27th is at Gurgaon. So we request you to participate, and all these subjects can be discussed there. Apart from that, on September 16th and 17th, we are going to have an international symposium. A lot of experts around the globe, experts from Europe, experts from US, they are also available as a guest in NFE, and we are making international symposium where you can also attend the points from the international participants. Now, as the final one, I take only one question from Dr. Pandian Guruswamy. Sir, if you have any question, please go ahead. With this, we will, after this, we will close the program. If you have any question, Dr. Pandian, you are free to ask now. You have to unmute and speak.
Good afternoon, sir. Thank you very much for your presentation, excellent presentation. It is very useful to all engineers. Sir, I have one question. As you mentioned in the presentation, if there is one more transformers in a building or industry, whether it requires separate earthing for body earthing and neutral earthing for each transformers?
No, there is a figure given. You please look at the figure. Hopefully you downloaded the standard. So there is a figure given. 1 minute, let me take the figure. This is a figure in Annexure F. Multiple conditions are given. One with one transformer, and one DG, and multiple. There is a figure F3. Typical schematic of earthing of multiple sources running parallel TNS system. You can have a look on this. So you will get the information.
Yes, yes.
Thank
Yes,
you.
sir.
Thank you.
Yes, sir. Thank you, sir. Thank you.
Thank you very much. Thanks
Thank you,
to
sir.
all
Thank you.
the
Thank you.
participants. Thank you, sir. Thanks to all the participants. We have a record participation today. We are so sorry that maybe the overcrowding, probably few of them must have been connected to the YouTube link. Your queries, of course, there are so many queries. We could not answer all the queries, but we will continue this process. Probably we can go chapter by chapter in the next programs. As a result, you may be getting a lot more information. As a result, the confusions in earthing can be cleared. And we are sure that once when the confusions of earthing is cleared, we can make a safer Bharat, electrically safe Bharat, and which is the vision of NFE, making Bharat electrically safe. With this, we would like to close the session for today. Let's see again probably next week or the week after. Thank you very much.